Hello. So let's now finish. We are now on question 7. So question, yes. So it says 0.150 kg ball on the end of a 1.10 meter long cord. Negligible mass is swung in a vertical cycle. Determine the minimum speed the ball must have at the top of the arc so that it continues moving in a cycle. And B, calculate the tension the cord at the bottom of the arc, assuming the ball is moving at twice the speed of part A. Alright, so first of all, let's just sketch and see this motion of the ball. Alright, so basically what we have is this is now the path of the ball. So let's make it to look like really it is a path. Alright, so if we can assume that this is the center, I hope I'll be right. Yeah, I hope. So what is basically happening is, so we have our string there. Okay, so we have our string there, and over all right. All right, whatever, however it will be. Yes, you can just, I think, reach at that point where we can say however it will be. All right, so and then over there it has got a ball. Okay, so that means my radius has changed. I mean my center has changed. It will now be here. All right, and as the question says, so over here we have got a ball. Yeah. So we have a ball here. Yes. So this ball is, swinging in this. It'll be swinging in this pattern. All right. Now it will be swinging in this path. That means yes, due to the centripetal acceleration. But now the question what is trying to say is we should determine the minimum speed the ball must have at the top of its arc so that it continues moving in a circle. So the minimum speed that the ball will have at the top here, you see, it will be due to the tension force in a string as well as the mass of as well as the gravity itself, which will sum up to give the what the centripetal force. Remember, it's like this, so that means it's going to have the centripetal acceleration, hence the centripetal force. So the centripetal force that will make this ball to be moving in this circle will be due to the weight of the ball as well as the tension in the string. Okay, so that is when we try to analyze it. But then when we look at the directions here, you're going to see that what's going to happen is the gravitational force will be acting downwards. Since the acceleration is downwards, so the gravitational force is downwards. So we have here the gravitational force will be acting downwards, and the um, the tension force also, right, and the tension force also will also be acting downwards. So this is a tension force will be acting downwards. Why is that happening? Is because acceleration is downwards. So this is the tension force acting downwards, and the other one is gravitational force the F of G, force of gravity, also acting downwards because the ball is going downwards, so it will be going downwards. So what we're trying to say is what we're going to have is you see, the equation now will be the force due to gravity plus the force due to tension, or we can just say tension force will be equal to the centripetal the force due to the centripetal acceleration. So all of them, they will be positive, as it has been seen here, because they are all acting downwards, as the graph here has. Now what you have to know is, even though this string has got a constant radius, but then what we're going to observe is the speed will be varying. It will reach at the moment whereby it has got a minimum speed and then has got a maximum speed due to gravity. Definitely it's going to have the maximum speed down here, but then yes, it will be varying as it revolves towards the center of gravity. Now looking back at the question again is determine the minimum speed the ball must have at the top of its axis so that it continues moving in a circle, because as I said, it will be having a minimum speed at the top here and the maximum speed at this bottom. So the speed will be increasing like that because you are moving towards the center of gravity here. So hence the speed will be more. But then because you're moving away from the gravity, then the speed will now be less. So I've said we have now chosen the downward direction to be positive. That means this one will be positive, this one positive, as well as the acceleration will be positive because it will all be pointing downwards. So now because they are saying that the minimum speed, and then they have said that we should assume, I think I've seen somewhere, the negligible mass in a code. Now because they have seen that in the first scenario the mass has to be considered as negligible along the code, as well as we want to achieve the minimum speed. That means tension force has to be zero, because we want to achieve the minimum speed the ball must have. At the same time, the minimum speed, yes, the ball must have, then that means the tension force will be a zero. Why? Because if you can see, if I come up with the equations here, it will be the tension force plus the force of gravity there, which is mg, is equal to the centripetal acceleration, which is m v square over r. So you're going to notice that the value of tension force depends on the velocity here. Okay, it depends on the velocity. The lower the velocity, the lower this value will be. So the minimum value, that means the tension force, will be zero. All right, so the tension force, the minimum value will have, the minimum value of the ball will be attained. That means the tension force will have to be zero. So here we're going to end up with mass times gravity is equal to mass v square over r, which means m is taken out, is equal to v square over r. From there you're going to see that v square is equal to gr, hence v is equal to the root of gr. And what is the root of gr? That's 9.81 times the r is 1.1. So this should give you the answer of 3.28 meter per second. So that is the minimum speed which the ball will have. So when it is on top, the minimum speed will be now 3.28, and according to because it's now the minimum, that means the force in the tension will be almost zero. So that's why we have and in fact they've even told us that the mass itself of yes, So that's now the how it will be. All right, and then the other part of the question is to calculate the tension, the chord at the bottom of the arc, assuming the ball is moving twice the speed. Yeah. Now, because like I said that the velocity of the tension force, I mean the magnitude of the tension force, will depend on the velocity of the ball. When it is at the minimum, this tension force will be very low. Okay, but at maximum now, or as the velocity increases, so is the tension in a rope also increases. So we want now to consider the tension force when it is at the bottom here. So when it is at the bottom, so let's try to imagine how it will be like if the string is now at the bottom. All right. I'm going to choose a different ink. All right, now the string now is at the bottom, and here the bow. Here the bow now is at the bottom. Now let's now evaluate. So when it is at the bottom, what we're going to notice is we are going to have here the gravitational force. Um, the gravitational force will be pointing downwards as usual. That's the force of gravity. But then you're going to notice that the tension force now will be upwards, because upon it reaches the bottom, the ball will have to, to revolve, to keep now going up, which means the acceleration also is upwards. So the acceleration also is upwards. So if we can set upwards being a positive and downwards being negative, it means we'll end up with this equation now. We'll end up with this equation that the tension force will be positive because of set upwards be positive. So it will be the tension force, but now the gravitation force is downwards, which means it will be negative, is equal to now due to centripetal acceleration. And this one again will be positive because acceleration is upwards. So from this one, they have asked us to find tension force. That means tension force, therefore tension force, it will be equal to m v square over r plus mg. I can factor out m is equal to v square over r plus g, which means my tension, I think will not fit. Therefore tension will be equal to, my m is 0.15 kg. Now they've said that on the speed, now they've said that assuming that the speed in this case now it is 2 times of a. So of a, the speed now we're not going to use this 3.1, I mean 3.28, but then maybe I should just write it here. The speed now we're going to use 3.28 times 2, which now will be something about 6.56 meter per second. So yes, 6.56. So that's the speed which we'll be using. So 6.56 square over r, which is 1.1 plus 9.81 meters per second square. So this is meter and this is meter per second square. Not per second square, but this one is meter meter per second square. And then here you should be able to get 7.34 Newton. So that is now the tension force which is going to have if the speed has doubled. So if it is at minimum speed, that means the tension will be almost zero. But then of course in reality it will be, a certain value but close to zero. That's why we said it to be zero. So this is how you are supposed to solve question number 7. Thank you very much. So this video has only covered question number 7. Thank you very much for your attention. Goodbye.